But we are in the 21st century and navigating with a map and a compass, well, we can do a lot better, right? When you are drunk,
If I could take you back to my youth,
then navigation is easy. You just simply know how to go back home every time.
in a moment I hung desperately. The other ring on my wrist is gold, pairing with the light.
When we are not drunk, then it doesn't work. Somehow when we're drunk, our place, grid cells, whatever is in the brain, it works a lot better than we are not drunk. And in that case, GPS comes handy. As we already said before, GPS can be used to track birds' migration. However, it has many other applications. For example, in geoscience, it is used to measure movements of the Earth's crust down to a couple millimeters. But how does GPS actually work? Well, it is complex. You may say, complex? Come on, I just take my phone, turn on GPS, and voila, I know where I am. And there are even things like this app which can show us all of the satellites around us, and even better, it has augmented reality, so I can actually see what satellites are exactly in front or behind me. GPS system is a combination of Einstein, Newton, Kepler and many other great minds. So let's have a look into that. In a nutshell, there are over 30 satellites broadcasting data in the GPS system. The broadcasted data contains a timestamp from a super precise atomic clock, its current location, and a couple of other information. GPS receivers, like smartphones, listen to the broadcasted signal. Once they receive the signal from at least 4 satellites, they are able to approximate the device's location. First of all, we have some satellite over here. And we are somewhere in the space. This is space, somewhere is Earth, somewhere is sky, whatever. So this satellite is broadcasting a signal to each direction, and it is broadcasting the signal as a sphere. So you have something like this. And I know my drawing skills are not perfect. And satellite is here in the middle. So if we have one satellite, you will know that you are somewhere on this sphere, anywhere on this sphere. Now, if we have second satellite, let's say here, and this satellite has a sphere, let's say like this, where it's broadcasting, again, sorry, then we can know that we are somewhere where these two spheres intersect, so we are somewhere here. Now, if the third satellite comes, and it has its sphere here, finally, we know that we are at the point where all the three spheres will intersect, and now we end up with these 2 points only. However, 2 points is not enough. Sometimes when we're on the ground, we can actually dedicate whether we are on one of these points, but usually not. And that's why we need the fourth satellite somewhere here, and at the place where 4 satellite broadcast signal will intersect is where we are. And at that point, our device, for example a smartphone, can calculate that we are at this point. To have GPS or any other satellite navigation system work, there is quite a few obstacles that have to be solved. First of all, everything is moving. If you are driving a car and you want to know your location, you are moving. And the Earth itself is moving around the Sun, with the galaxy, with the solar system. Then the satellite, of course, is orbiting around Earth. The gravitation on the orbit is weaker than the gravitation on Earth.
What?
And every day we have to account for 38 nanoseconds change in time. The difference in time between the satellite and Earth. Finally, the orbit, of course, on which the satellite is, it's not a perfect circular orbit, it's some kind of an ellipsoid. And this also means that at different place on this orbit there is a different time change to us. the signal that is reaching Earth, it's traveling through a long time, thousands of kilometers, and because of that the signal is getting weak once it gets to Earth and it's easy to override. So if there is another broadcaster that broadcasts some signal at the same frequency, it will be easily overriding the satellite signal. This is solved usually by having more than one frequencies at which the satellite is broadcasting. And finally also, receivers usually don't have atomic clocks on board, so they don't have such an accurate time measurement as satellites. And this is why we can only know our position when we use our smartphones up to about 5-6 meters. And of course, these are only some examples of the obstacles that are met with developing such an advanced system. And more details, if you're interested, check out this link, and there is a perfect series of videos that describe every single detail of the satellite GPS system, and it's all free on YouTube.
The remarkable thing about this is that thanks to the GPS measurements, we know that every one of us, unless we were in an airplane at the time, was moved by this earthquake by several centimeters.